I have to ask about beautiful artificial life systems or evolutionary computation systems. Cellular automata to me, like I remember it was is a game changer for me early on in life when I saw Conway's Game of Life, who recently passed away, unfortunately. It's beautiful
Yeah.
how much complexity can emerge from such simple rules. I just don't somehow that simplicity is such a powerful illustration and also humbling because it feels like I personally, from my perspective, understand almost nothing about this world because like my intuition fails completely how complexity can emerge from such simplicity. Like my intuition fails, I think, is the biggest problem I have. Do you find systems like that beautiful? Is there do you think about cellular automata? Because cellular automata don't really have and many other artificial life systems don't necessarily have an objective. Maybe that's a wrong way to say it. It's almost like it's just evolving and creating.
Yeah.
And there's not even a good definition of what it means to create something complex and interesting and surprising. All those words that you said. Is there some of those systems that you find beautiful?
Yeah. And similarly, evolution does not have a goal. It is responding to the current situation, and survival then it creates more complexity, and therefore we have something that we perceive as progress. But that's not what evolution is inherently set to do. And yeah, that's really fascinating. How a simple set of rules or simple mappings can from such simple mappings complexity can emerge. So it's a question of emergence and self-organization. And the Game of Life is one of the simplest ones and very visual, and therefore it drives home the point that it's possible that nonlinear interactions and this kinds of complexity can emerge from them. And biology and evolution is along the same lines. We have simple representations. DNA, if you really think of it, it's not that complex. There's a long sequence of them. There's lots of them, but it's a very simple representation. And similar with evolutionary computation, whatever string or tree representation we have and the operations, the amount of code that's required to manipulate those is really, really little. And of course, Game of Life even less. So how complexity emerges from such simple principles, that's absolutely fascinating. The challenge is to be able to control it and guide it and direct it so that it becomes useful. And like Game of Life is fascinating to look at, and evolution, all the forms that come out is fascinating. But can we actually make it useful for us?
And efficient, because if you actually think about each of the cells in the Game of Life as a living organism, there's a lot of death that has to happen to create anything interesting.
Yeah.
And so I guess the questions for us humans that are mortal and then life ends quickly, we want to kind of hurry up and make sure we make sure we take evolution the trajectory that is a little bit more efficient than the alternatives.
Yeah. And that touches upon something we talked about earlier, that evolution computation is very impatient.
Yeah.
We have a goal, we want it right away.
Yeah.
Versus biology has a lot of time and deep time and weak pressure and large populations. One great example of this is the novelty search. So evolutionary computation, where you don't actually specify a fitness goal, something that is your actual thing that you want, but you just reward solutions that are different from what you've seen before.
Yeah.
Nothing else.
Yeah.
And you know what? You actually discover things that are interesting and useful that way. Ken Stanley and Joe Lehman did this one study where they actually tried to evolve walking behavior on robots. And that's actually, we talked about earlier, where your robot actually failed in all kinds of ways and eventually discovered something that was a very efficient walk. And it was because they rewarded things that were different that you were able to discover something. And I think that this is crucial because in order to be really different from what you already have to utilize what is there in a domain to create something really different. So you have encoded the fundamentals of your world, and then you make changes to those fundamentals, you get further away. So that's probably what's happening in these systems of emergence. that fundamentals are there. And when you follow those fundamentals, you get into points, and some of those are actually interesting and useful. Now, even in that robotic walker simulation, there was a large set of garbage. But among them, there were some of these, gems. And then those are the ones that somehow you have to outside recognize and make useful. But these kind of productive systems, if you code them the right kind of principles, I think that they that encode the structure of the domain, then you will get to these solutions and the discoveries.